This is going to be one of my basic earth science topics, as well as, remember in my Teach Smarter, Not Stricter videos, if you've come across those, when I mentioned that if I want to really understand the truth about global climate, global warming, and climatology, I would need to study the topic again from the ground up, all over again. Well, here's one of the basics: the carbon cycle. Carbon is one of the most abundant and important elements on Earth. It is, in fact, the fourth most abundant element in the universe, following hydrogen and helium, which is what stars are made of. And oxygen is the third. Hydrogen and oxygen, in the form of water, is actually quite common in the universe. It's just usually frozen. And, you know, in searching for life, we're looking for liquid water as well as a planet that has the right conditions to sustain it. The sheer abundance of carbon does suggest that, were we to find extraterrestrial life, it has a high probability of being carbon-based, and we should expect to find life on a world that has an active water and carbon cycle. So let's talk about how the carbon cycle works on Earth. When I was in school, studying my chosen field of environmental science, I must have had to return to the carbon cycle about 10 or so times over numerous years. School once or twice would have sufficed. It's not that difficult to learn. Nearly all of the energy on Earth originates from the sun. There is some energy generated from within the Earth itself, geothermal energy that comes from the currents of magma under the crust, set in motion during the planet's formation, but it's mostly from the sun. I will talk about how photosynthesis works another time. This video is just about carbon moving through the environment. There's carbon everywhere. Okay, there's carbon in continental rocks, there's carbon stored in the oceans, in magma, in biological organisms. What climatologists are interested in regards to global climate and global warming, is carbon gases in the atmosphere. And we'll get to that. Sunlight powers photosynthesis, which allows plants, as well as some bacteria, most notably cyanobacteria, to produce sugars for food so they can grow. And they are eaten by herbivores, who are eaten by carnivores, and this leads into the whole study of food chains and food webs in the planet's ecosystems. When living creatures die, the remains decay and their carbon returns to the soil and the rock, the seafloor and the oceans, and this organic carbon, when it is compressed under layers of soil and rock for many millions of years, can become coal and oil, and can remain trapped in the planet's crust for very long periods of time. So there's lots of organic carbon in the ground, and some of this carbon is used by plants to grow. Again, plants are eaten by herbivores, herbivores are eaten by carnivores, and so organic carbon transported through the food web. And then that mini cycle goes on as living creatures die, plants take up the carbon in the soil again, and that's that mini cycle. Now, throughout their lives, animals respirate. They inhale oxygen and release carbon dioxide. And plants also respirate to a small extent, but they are amazing carbon sequesters overall. Carbon sequestration, you'll hear that term if you get into climate science or earth science. It means the storing of carbon inside a living being, such as a tree, an environment such as a forest on a larger scale, in rock layers, ocean water, and so on. Carbon storing. So how does carbon get into the atmosphere? Well, carbon dioxide, CO2, is naturally in the atmosphere. The Earth's atmosphere is about 80% nitrogen, 78% to be more exact, 21% oxygen, O2, that's the oxygen we breathe. And then the remaining 1% is trace gases, meaning gases in small proportions compared to the sheer volume of atmosphere that the Earth has. Carbon dioxide, which is 1 carbon plus 2 oxygens, we can't use that oxygen when it's attached to a carbon, and the reason lies in complex molecular science, but carbon dioxide is exhaled by living organisms as a waste product. Even plants do this to a small extent. Organisms will also release methane, which is CH4, 1 carbon plus 4 hydrogens, and it's a greenhouse gas about 20 times more powerful than carbon dioxide. Carbon is also released when we burn fossil fuels. Remember, the carbon stored in organic remains, plant material, under pressure for millions of years becomes coal, fossilized plant and animal material also becomes oil, and when these are burned for energy by humans, the carbon stored within them is released into the atmosphere. It's also released when coal and oil burns naturally. There's nothing different about humans burning these fuels, it's just that their stored carbon is released as gas. Organic matter decaying also releases carbon. Volcanic eruptions release carbon gases into the atmosphere as well. Asteroid impacts, these colossal eruptions and explosions that have occurred every once in a while in Earth's history, release way more carbon dioxide and other greenhouse gases than humans produce. It's just that those eventually subside and the carbon gets stored in the environment again, whereas the concern with human activity is that it's constant. It's always going on. What people are worried about is the balance of these gases in the Earth's atmosphere, how to maintain a livable balance, and how to manage resources. And that is a whole series of discussions, which we will get into eventually. Scientists study this for decades, and we still can't give people much certainty. It's immensely complex. So we'll go there. Yeah, this was just about the carbon cycle and how carbon travels and cycles through the environment. If you're curious about or studying any kind of earth science, be it climatology, ecology, resource management, petrology, or you just have to pass that earth science test, this is a very key component to become familiar with: the carbon cycle.